Welcome to This Explainer. Today, we're tackling one of the most confusing, heavily overloaded words in the entire tech ecosystem, operator. Depending on who you're talking to, this single word can mean a math concept, a digital marketing strategy, or a highly advanced robotic facility manager for your cloud infrastructure. Let's be real. Developers aren't exactly known for their creative naming conventions. So we're going to untangle this web today and look at the tale of three operators. Okay, let's really dive into this. How can one single word mean so many wildly different things depending on who you ask? Think about it. If you sit a software engineer, an SEO specialist, and a DevOps engineer at the same table and ask them what an operator does, you're going to get three completely distinct answers. It's honestly a fascinating study in how language evolves within specialized disciplines. Just look at these three distinct syntaxes side by side. On one side, we have standard C++ code using mathematical symbols. Right in the middle, a very specific Google search query. And over on the far end, declarative infrastructure logic used in cloud environments. All three of these are universally referred to as operators by the professionals who use them literally every single day. To make sense of all this, here's our roadmap for today's explainer. We'll decode the word itself, explore actions in programming code, look at how we filter the web through search, scale things up to cloud automation, and finally, uncover the shared philosophy that ties this whole thing together. All right, let's start with part one, decoding the word operator, creating our disambiguation framework. Which brings us right into part two, programming, where operators act as mathematical machines in our code. In the realm of computer science, an operator is essentially a mathematical machine. It's a language construct that gives you functionality, but it uses a syntax that's entirely different from your standard user-defined function. Instead of writing out a clunky prefix function like add with x and y in parentheses, languages give us these familiar infix symbolic operators. So you simply write x plus y. It's designed to make the code look way more familiar and readable, acting directly on the given operands. Within this programming context, we can break operators down into a few core categories. For math, we've got arithmetic operators, like addition. When we need to test conditions, we use relational operators, like checking if A is greater than B. Then there are logic operators, like A and B, which evaluate multiple Boolean conditions. Sometimes these even use short-circuit evaluation, where later arguments aren't even looked at if earlier ones already prove false. And importantly, we have assignment operators, which actually replace a target's value rather than just evaluating it. Now, things get super dynamic when we introduce something called ad hoc polymorphism, which you might know better as operator overloading. This means the exact same symbol can perform totally different actions based on its context. For instance, in Java, the plus symbol can sum two numbers together, or it can concatenate two text strings. Furthermore, we have compound assignment operators, like plus equals. This doesn't just evaluate a result, it actively modifies the state of a variable stored in the computer's memory. The operator essentially acts as an agent of change within the RAM. Fun fact for you, giving the same symbol wildly different powers is exactly why poorly documented operator overloading is pretty much the sworn enemy of junior developers everywhere. But here's a fascinating paradigm shift. What if you aren't a software engineer compiling code? The word operator takes on a completely different, yet equally powerful meaning. Let's pivot for a second and shift our focus to the world of digital marketers and researchers. That leads us into part three, search, filtering the web using what is essentially a librarian system. In the world of search engines like Google, advanced search operators are special commands that filter results to make them incredibly precise. Think of them like a highly advanced sorting system for a massive library. But you do have to be careful here. Reliable working operators include things like site:, file type:, and in title:. However, in classic Google fashion, they've silently killed several others over the years. The tilde symbol for synonyms, link:, and phonebook:, are all deprecated now and are completely ignored by the search engine today. Let's look at how you'd actually apply these tactically. You can combine them to achieve highly specific goals, like uncovering hidden indexing issues on a website. Step 1. You target a specific domain using the site:, operator. Step 2. Filter for specific document formats using file type:, PDF. Step 3. Review the results. This exact combination is a classic move to discover lead generation assets, like private white papers that were accidentally indexed by Google and left totally exposed to the public because someone forgot an X-Robot's no index tag. The operator here is basically a tool for highly targeted discovery. Scaling things way up, we arrive at part 4, cloud, automating the infrastructure with a robotic manager. Now, how Kubernetes and cloud-native environments redefine the word operator is where things get truly massive. In this context, we're talking about the operator design pattern, which is used to manage complex applications by capturing human operational knowledge and baking it directly into code. A user simply provides a declarative requested state, basically how they want the system to look. The operator then compares this to the current status of the system. It feeds both of those into its operational knowledge software, allowing it to apply changes and manage resources totally autonomously. And the engine driving this entire process? It's the continuous control loop. A Kubernetes controller is constantly watching external events, the current state of the application, and the custom resources defined by the user. Its sole purpose in life is to reconcile all of that incoming data to ensure the actual real-world environment perfectly matches your desired state. It essentially acts as an executable runbook, replacing tedious, repetitive human tasks with a relentless, automated system. To really break down that reconciliation loop, the cloud operator basically follows 3 exact tactical steps on repeat. First, it observes. It checks the current state of the database or application. Second, it differentiates. It compares that reality against the declared desired state provided by the engineers. And third, it acts. If there's any drift between reality and the desired state, the operator runs specific routines, like deploying clustered software or executing automated backups, just to maintain system health. Which brings us to our final stop, Part 5, the shared philosophy, operators as agents of change. Let's tie this all together and build a unified picture. We started with code, where an operator is a mathematical machine modifying variables. We moved to search, where the operator is a librarian filtering massive data streams. Finally, we looked at the cloud, where the operator is a robotic manager continuously reconciling infrastructure. Despite these vastly different contexts, the shared philosophy is actually remarkably clear. In every single one of these domains, an operator is fundamentally an agent of change. It takes specific inputs, applies a layer of specialized logic, and ensures a precise desired output. And that leaves us with a pretty profound question to wrap up this explainer. We've seen how the definition of an operator has scaled from a simple plus sign on a chalkboard all the way up to a complex, autonomous manager of global cloud infrastructure. But now, as artificial intelligence agents are starting to write their own code, run their own advanced web searches, and autonomously manage their own cloud environments, what is the operator of the future actually going to look like? Are humans going to step out of the loop entirely? It's definitely something to chew on. Thanks so much for joining me today, and as always, keep questioning the technology around you.